Guys, so this video is going to be all about electrons, their pattern, where they are in the atom, and all of that sort of thing. So here we have a Bohr model because it's the easiest to draw and it serves for the purpose for our basic function. So at the very center of the atom is the nucleus where you have your protons and your neutrons, and then you have rings going around it all the way up to 7, which are the individual energy levels. And so the first energy level has the lowest amount of energy, whereas the 7th energy level has the highest amount of energy. And so when you're looking at this, every energy level in an atom contains a different number of electrons. And so this also corresponds to your periodic table, which I hope you have out in front of you. So every period or row on the periodic table represents one of the energy levels. And so the first row represents the first energy level, the second is the second energy level, etc. And so with this, all of the electrons have what we call a unique address within the atom that chemists call electron configuration. And the word configuration just means how it's arranged or organized. So if you think about how mail gets delivered to your apartment or to your house, it's because every building and place has a very unique address. And so all electrons also have an address that no other electron can share. So within each energy level, each energy level has a different number and type of sublevel. And in the sublevels, depending on the type of sublevel, it each contains a different number of orbitals, those regions of space that we talked about electrons being in, and each orbital can hold up to 2 electrons. And so, in case you missed that, you have each of these 7 energy levels represented by the 7 rings, and in those energy levels there are sublevels, and inside the sublevels are orbitals, and each orbital has 2 electrons. So it's kind of like one of those, you've ever seen those Russian doll dolls where they all fit inside of each other? That's kind of what's happening here. And so the electrons on the outer energy level are called valence electrons, and those are going to come in into a big deal. They're a big deal. They're used for bonding, and you're going to need to be able to calculate them. And the symbol we use for valence electrons is the symbol for an electron with a V in the front. And so remember, in each energy level, they contain a different number and type of sublevel. And so the 3 types are S, P, D, and F. And the S sublevel looks like a sphere, okay? And so it's just kind of like, well, a circle, but 3-dimensional. And inside the S sublevel, there's 1 orbital. And so because every orbital can hold 2 electrons, that means this only has 2 electrons total. Now, the P sublevel looks kind of like this, but more of like a dumbbell, like you work out with, where the center part, that's a node or a place where electrons are not, because that's where the nucleus is. That node kind of goes right where the nucleus is, and the P has 3 orbitals, and that means there are a total of 6 electrons, because 3 times 2 is 6. And the D sublevel looks like this, where that is 1 of them. So the 3 P sublevels, there are 3 of this shape. For the D sublevel, there are 4 that are of this shape, and then there's 1, the 5th one, that kind of looks like you have a figure 8 inside of a donut hole. And so there are 5 total, and in those 5, 2 electrons each, so that's 10 electrons total. And the F-shaped one looks like this. So that's just one. And there are 7 of those that are inside the energy level, and that means there can be a total of 14 electrons. And so the way that kind of looks when you kind of layer them on top of each other is like, so the first energy level has one sphere, and then your second energy level has a sphere and the 3 p sublevels. And then your third energy level has a third sphere, and again, 3 of the p orbitals, but you can see that they're getting bigger. And then you have the 3D, which would add even more complication, and so it kind of looks a little crazy. This is my beautiful artwork, but that's why you can see we draw the Bohr model in class. This would be extremely complicated, but essentially they layer on top of each other. These sublevels and energy levels and orbitals are all represented on the periodic table. So we have a blank periodic table here, and so the first thing is that every box on the periodic table represents a different electron. And so with each electron, it has a unique configuration that's a combination of its energy level, the sublevel, and the total number of electrons in each. And so when you look at this, the energy levels are the rows. So this would be the first energy level, second, third, fourth, fifth, sixth, and seventh. And then these two down on the bottom are also part of the sixth and seventh energy level. They kind of pop in right here at these 2 stars, but the reason why they're down below is literally to make the periodic table fit on one page. If you were to insert them in, it would go really long, and that would be kind of obnoxious. So scientists kind of condensed it to be like this. So we have 7 energy levels, and you can see that in this first energy level, you have 2 boxes. And so, and in the second, third, and fourth, these first 2 columns represent the s orbital. And so you can see that this box where helium is also kind of represents like that little box, but it got moved over because helium has chemical and physical properties more similar to the ones over here. And so those are the s orbitals. And you can see that in the s orbitals, there are 1, 2, 1, 2, 1, 2 boxes because the s orbital or the s sublevel has 1 orbital that can hold 2 electrons. So it's just 1 orbital. But the p sublevel is represented by these boxes over here. So these are all the p sublevel, and you can see that there's 1, 2, 3, 4, 5, 6 boxes, or 6 electrons. And so if you divide that by 2, you can see that the first 2 would be 1 orbital, these 2 are an orbital, and the 2 at the end are an orbital. So we have 1, 2, 3 orbitals in the p sublevel, or 3 groups of 2, and 6 total electrons. Now the center is represented by the d sublevel. Now the important thing to know about the d sublevel is you actually have to subtract 1 energy level. So what I mean by that is this would be the 4s group, but this is not 4D. This is actually, this whole row represents the 3D sublevel, and that is because 3D, because of its awkward shape, is actually higher in energy than 4s, so it's kind of staggered that way in terms of how the electrons fill in. And we can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes one for each of the 10 electrons that are in the d sublevel. And so that means there are 1, 2, 3, 4, 5 groups of 2, so 5 orbitals for 10 electrons each. And then this bottom section here that got pulled out is all of the f orbitals, well, the f sublevel, and the f sublevel has 7 orbitals for a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's because this, so it would be more accurate to say that these here, let's rearrange that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It looks like there are 15, but that's because these are repeated here, so it's kind of showing up twice. That would be 7 groups of 2, so that would make 7 orbitals for 14 total electrons. And so every electron's unique address, or its electron configuration, is represented by its energy level, the sublevel, and which electron it is. So if we look at this example over here in the bottom right corner, we can see that the 4 represents the energy level. I'm going to just, so the energy level. The S represents the sublevel, and the 2 represents the electron. And so what I mean by that is 4s2 would mean we look at the 4th row, the s block, and the second electron. So whichever element is there, that is its electron configuration. Well, its ending electron configuration. And now that we've kind of got the basics of all of this, the next video will actually give practice for how to look at the electron configuration and write it.